Hey everybody, it is Mr. Webb and Mrs. Cox, and it is demo day. We have kind of a small demo today because we're reviewing, but we've been learning about density and Earth's layers. As you can see, Earth's layers, we've learned that the crust is solid and it's the outer part. The mantle is solid, the outer core is liquid, and the inner core is solid. But we haven't been able to drill there, so how do we know? Scientists have been trying to dig to the mantle for years and years and years. There's an old saying, say you're going to dig all the way to China. That actually is not possible as of right now. They have only made it 12 kilometers and they had to stop because the temperature was so hot that their equipment couldn't handle it. The crust is actually an average around 30 kilometers and they've only made it 12, so they have a long way to go. So you got to ask, how do they know that the outer core is liquid, the mantle is solid, and the inner core is solid? Well, here's how. Scientists use earthquake waves to determine what is inside the Earth. They can track earthquake waves by seismic stations all over the world. So when an earthquake happens, they keep track of where the waves go. There's different types of earthquake waves. You have surface waves and you have body waves. The body waves travel inside of Earth, and there's two types. You have P waves and then you have S waves. So they both travel differently. P waves can travel through solids, liquids, and gas, and they're the fastest. So they can track those, and those go sometimes all the way to the core and bounce off. So they can tell that it can travel through solid. But S waves are a little bit slower and they cannot travel through liquid. So when they track the S waves, they bounce off the edge of the outer core is the farthest they've ever made it. So they have to know that the outer core must be liquid because it cannot travel through the outer core. One thing that scientists have observed is that if an earthquake happens on this side of the world, then the waves will not reach this side of the world. That is because the core is so hard that they cannot travel all the way through the core. So P waves can travel to the core, but then they can't go through the core. So if an earthquake happens here, they have discovered that on one side of the world this is happening and you can feel it all over the outside, but underneath there's something they call a shadow zone. So when the earthquake happens in a certain area, the shadow zone is a place that will not feel it because the waves can't travel through the center of the Earth. So if we had an earthquake here, if China was exactly on the other side of the world, they would not feel it. And when an earthquake happens somewhere, maybe over here, you can still feel it up here or over here, but not on this side. Some of the earthquake waves travel, they're so light that we can't feel them, but the seismic stations can actually track them if they're really far away from you. All right, now that you know how scientists have figured out what the layers are made of, we're going to show you a really short demo that has water and a fish bowl, the one we used for the lab the other day. But this time we have a little jar in the center, right here. That is going to be Earth's core, and then this is the Earth. So this, we're going to imagine, is the Earth, and this is really solid. And the penny is going to be our earthquake wave that goes into the water. Miss Cox is going to drop the penny, which is going to be the earthquake, and as it travels through Earth, that's going to be your earthquake wave. So if you watch, when it hits here, it doesn't go directly to the core. It's actually causing waves, and it may bounce all over the place like it's traveling through Earth. So here we go. So that time it traveled all the way over here. You notice it didn't go straight down, so it would have been bouncing off things inside of Earth, and the scientists would have tracked those waves. If you noticed it, this would have been your shadow zone because it ended up over here. This time, we're going to imagine that the Earth is hollow and watch the earthquake wave as Miss Cox lets go of the penny. Straight down to the other side. So if there was nothing inside of Earth, it would have traveled straight through to the other side, like China down here or whatever the shadow zone would be. But since there is solid and different densities inside of the Earth, they tracked all the waves, like S waves that go way over here, or P waves that travel straight and fast. They don't go in a straight line, so they travel kind of all over the place. All right, we're gonna use a wave machine to kind of show you an example. So this would be like your epicenter where the earthquake starts, and it would travel all the way down here and deflect off of something hard, and then it comes back, and the scientists track it over here. So this is where it starts, this is where it ends up, and they can tell by the time how far it went before it bounced off something. So here's an example. All right, hopefully now you have a better understanding of how scientists figured out what Earth's layers are made of. They spent years and years and studied thousands of earthquakes to figure this out, but that is the only way they can figure it out because we haven't been able to travel there yet. because it's too hot. But maybe someday, you know how science changes sometimes. But as of right now, that's all we know. If they could dig there someday and find out a different way, then I'm sure it'll change. But hopefully you have a better understanding, and that was Demo Day. If you learned anything today, just remember the Earth